Hello everyone. The topic for today is area of parallelograms. Right now I want you to pause the video so you can copy down your notes and then resume when you're ready. So a parallelogram is a two-dimensional figure with opposite sides parallel and opposite sides the same length. So that means that this side and this side are parallel, this side and this side are parallel, and this side and this side are equal in their length, as well as this side and this side are equal in their length. A rhombus is a parallelogram that has four equal sides. So it's similar to a square, but there's no right angles. The base of the parallelogram can be any of its sides, and then whatever side is perpendicular, the perpendicular distance from the base to its opposite side is the height. So for example, if we were looking at this parallelogram here on the top, if we're saying that this is the base, then the distance from this side to this side would make up the height. A good rule of thumb, anytime we're dealing with height, especially in the geometry unit, anything that is the height is going to make a right angle. So you have to look for the right angle. And if you think about how height is measured in people, height is always measured straight up and down. So you've always got to look for something that's going straight up and down, which again would find that right angle. So the formula is base times height. So again, it's very similar to finding the area of a rectangle, but we've got to make sure that we're using the correct measurement for the height. So here in this example, the base is 9 inches. The height is 5 inches because, again, it goes straight up and down. The 7 inches, that's at a slant. That's just extra information, so we don't need that. So 9 times 5 gives us 45. The measurement is in inches, so the area is 45 inches squared, or square inches. Next example, we've got another parallelogram here. The base is 16 yards. The height is 14 yards because that is what goes straight up and down, forms the right angle. The 15 we don't need because it's just extra information. It's slanted, okay? So we're going to multiply 16 and 14. And we get 224, so the area is 224 square yards. For problems like number 2, we have to find the area of the shaded region. So we're looking at finding the area of the rectangle and then subtracting the area of the parallelogram in this case. So in order to do that, we have to first find the area of the rectangle, which would be 31 times 18. And once we have that answer, we're going to subtract it by the area of the parallelogram, which would be 13 times 6. So we do 31 times 18. Oops. Let's fix that. So 31 times 18 to give us the area of the rectangle, the outer shape, which is 558. So that's this shape out here. Then we have to do 13 times 6 to give us the area of the inner shape, which is 78. So that's this shape right here. In order to find the shaded part, we've got to subtract that. It's kind of like just saying, okay, well, if we cut out that piece, how much is left over? So after we subtract those two numbers, we get 480. So 558 minus 78. We get 480. Measurements are all in millimeters. So 480 millimeters squared is going to be the area of the shaded region. Looking at a problem like number 5. So in problems like these, we have to count the number of squares that make up the dimensions. So looking at the base across the bottom, we've got 1, 2, 3, 4, 5 squares that make up the length of this base. So our base is 5. The height, again, goes straight up and down. So from the bottom to the top goes 1, 2, 3, 4, 5 units. So we multiply 5 times 5. That gives us 25. No units are given to us, so that means that we have to write the word units. It is area, so it's units squared. So there's our answer. So I want you to solve number 3 and number 4. Bring those answers along with any questions that you may have with you to class tomorrow.